Assalamualaikum friends. Today I'm gonna start another lecture which is how to design and analyze a beam in Sap 2000 version 14. So I have some specifications here right for you that today which beam I'm gonna design. I will show you the steps and you have to follow these steps to design and analyze the beam. So first of all, let's see which are the demands, which are the load, and what are the which type of the beam I'm gonna use. So look, here is the given data of the beam, which is continuous beam because we have two spans, span 1 and span 2. It's a data that we have two spans and the length of span 1 is 20 feet and the length of span 2 is 20 feet. And he's also shown us that we will use the cross section of 12 by 18 inch and the compressive strength of concrete will be 4000 psi, which are steel will be of 60,000 psi, and loads are given as well. So that load is 0.75, live load will be 1.2 kip per foot. So in SAP we are using design code of the CI 2005, which is built in the SAP. So let's start. First I will create a new model by clicking in file menu and now new model, or you can just click on this button. This is showing that new model. In this screen, what will I do? We will have to first identify our units. So here I am gonna use kip, feet, Fahrenheit units for my, and now I am gonna design a beam. So I am using a template of beam right shown over here. So look, here are two options: number of beams, number of spans, and span length, right? So when you are just going to directly click OK on it, it will take two spans of equal length. But in our data, we have two different span lengths. So for that, we will use custom grid spacing. Just check mark on it and edit grid button will be. You will click on this and another window appears. In this window, look, here we have two options. Either you are gonna give coordinates of these 3 points, or you are going to give spacing. So if I'm going to click on spacing, so what will happen? I'm gonna have 20 feet in one direction. I will have 15 feet in other direction, while my C point will be on 0, right? So I will have to click OK, right? Now from here again I will click OK. So look, here are two spans. Look, this span, if you select this member and then right click on it, it will show you its location, assignments, loads and design. For designing, we will come to the define tab. In define tab, first we will have to define the materials. If you click on it, a window will pop up, and this window already two materials are predefined. One is 4000 psi, so definitely it will be concrete, and another is A992F550. This is for steel. So if you just click on the 4000 psi and click on the modify, so there is the detail of their concrete properties. So here you can change each and everything according to your desire. So our have wet vaginal volume of 1.15 concrete and specified concrete compressive strength is 576 KSF. So mind it, this is in KSF because our units are set into kip, feet, Fahrenheit. So if we just change it into kip, inch, Fahrenheit, it will show you to the 4 KSI. That means 4000 psi, right? Now you can just rename it from here. Just write concrete over here, concrete of 4 KSI, right? Press OK. Now you will have to define some reinforcement bar in it. For that, select this and then click modify. Now you can just change the name of it. You can write it as reinforcement RFT, and as reinforcement are also the steel, but here another term is defined which is known as rebar. So this rebar will be used as reinforcement. So select rebar from the drop down menu. So now again, here are some different values. You can apply it on according to your demand or according to your choice. And then you can apply these values according to your choice. Now look here, the elasticity of modulus is also defined. Poisson ratio is defined. 40 and 60, all the things are defined. So what you to do, just simply press OK. Now press OK. So your material job is finished. So what happened next? Go to define tab again and give the section property. The next thing is go to define tab, set the section property and go to frame sections. In style sections, click on add new property. So in add new property, you will have to select concrete from here and then rectangular, right? So now rectangular. Now you have to give depth and height. So look that you have set your units to keep feet in Fahrenheit. So you will have to give the depth and width of the beam in Fahrenheit. So what was the depth of beam? It was 18 inches. So you can just write 18 inches, but to convert it into feet, you will get 18 by 12. Press enter. It will give you 1.5. Similarly, our width was 12 inches. So 12 divided by 12 will convert it into feet, or you can just press shift and enter. It will calculate, it will open up the Sap2000 calculator. So you can just use your formulation over here. So 12 divided by 12 or something like that. Press calculate. It will calculate for you and then press. You can use this as well. Now you have to show a concrete reinforcement details. Just click on it. Now you are designing the beam, so select beam over here. Now here you will have to define the clear cover of the concrete over the reinforcement bars. For that I am just pressing shift and enter and I am doing some calculation over here. So I am using the concrete cover of 2.5 inches. So as our system is in feet, I will convert it into feet. So this is the result. Okay, so again I am using same over here, 2.5 divided by 12. Press enter. It's calculated. So nothing else is required in there. Press OK, and you can change the name as well. Change it to beam and press OK. Beam and OK. Right. So the next thing, now go to define again, and now you have to go to the load patterns. Right. Now you have to define which type of loads are coming on your structure. So first, it's already taken as dead as the default. Now I'm going to add another. For that, our structure has dead load and live load. So here I'm taking now as live load. Here it will be live load. You can just select it by drop down menu. This is the live load, and its multiplier, self-weight multiplier, will be 0 because there is no self-weight included in the live load. Now you can just add this new load pattern and press OK. Now go to define again, go to the load combinations. Here you can add a new combo. Combo means a new combination. So this will be a combo one. You can just change it into your own choice. You can change the name. So I can say that my combination, right? So here you have selected two loads, which is dead load and live load. You have to give a scale factor to each load. So according to ACI, we use a factor of 1.2 for the dead load. Press add, and for the live load we select the factor of 1.6. Press add. Nothing else is required into this. So press OK. And another thing, you can also add default design combos. If you click on this and you are going to choose it for concrete and press OK, it will automatically select 2 or more according to the design. It will select combination. So one is this. If you can see the properties of it, just click on modify and you can see In this combination it is taking just dead load with 1.4 scale factor, while the other one is taking the dead and live load with 1.2 and 1.6 as we given him earlier. So press OK and press OK. So this is done. Now what have you do? We have to assign loads to our structure. For that I have to select the members. So selection can be done in different ways. Either you can just click it on them and then click on it, it will select it, or you can move through the windows. If you move through this window, look, if you are moving from right to left, everything intersecting the window will be selected like we did in AutoCAD, and if we move from left to right, the things coming in between the window will be selected like this joint. So if I'm going from left to right, all thing is selected, but if I'm going from this to right, I have to select this as a whole, right? So you have to just press select all, or you can also press this button, look, select all as well. So now what you have to do, you have to go to assign, and now here I have to give frame loads over there, and in our case the load is distributed. So click on distributed. So we are giving that load, and the whole thing will be the remain the same. We will add to replace we will replace the existing loads, and here we will give our intensity. So our intensity was 0.75 kips per foot, right? So this was 0.75 kip per foot. Press OK. So it includes the self-data structure on your beam. So the next thing is you have to assign live load as well. So go to assign, sorry, first you have to select all this. So you can select it another way with different ways I have shown you before, or you can just click on this button, get previous selection, and it will select all the previous selection which you have selected. So go to assign again, go to frame loads, and go to distributed, and this time you have to give it live load. So again the same, we will have to replace the existing load, but intensity is changed into 1.2, which is key. That's okay. So 1.2. Now if you want to see that which loads are included, just click on the member and press the right button of the your mouse and go to loads and look where it will show you distributed force 0.7580 and 0.7520, which is dead load, right? While the live load is 1.280 and 1.2820 in this point. That's okay. So both the dead and live loads are accommodated there. So if you check this, go to loads and again look, 0.750, 0.7515, 1.2 and 1.280. So that means both the loads are applied on the structure, but here it is just showing us the recent one which we applied. So what the next thing we have to go to design, and from here we have to select concrete design, frame design. So view the preferences, and you have to select this SEI 31805, which is the code demand for us, and press OK, right? After that we have to select the design combos. So select design combos and look, it has already selected these two combination which it picked automatically, but we also made one which is my combination. We can also add this. Now press, just you can unclick this thing and press OK. We have to analyze the beam. For that, first we have to go to analyze, and first we have to set analysis options. Right? In analysis option we can do some space frame, plan giving space stress, but here we are interested in 2D, so plan frame and then press OK, right? So in the next thing you have to run the analysis, either from go to analyze and run analysis, or you can just press F5, the shortcut, or run it. So click this, and now here you have to show which actions do you want to run and which you don't want to run. So in this case we want all of our actions to be run, so just letting run, or you can just run or do not run it from here. So let it run and not run not model. So it asks me to save the model, so I'm just going to save it here right from my main beam and then pressing OK. It is saved, and that's, look here, it has just shown me the deflected shape of the beam. So let me just maximize this window. Look, so this is our structure. So you can just change the views and you can see the deflections. So here now you can use these three buttons most widely to show you. So this will be show you undeformed shape, this will show you the deformed shape. You have to show wide shadow or cubic cut, just press OK. So this white lines shows you the original beam and this yellow line showing you the, let me go through this. Look, so this white line was the original beam and now this load was applied and now it's showing the deflected shape of our beam. So you can just click on this button and here just click fill objects and then use the extrude view to get clear view. Look, so this is our beam. Right, so it is just deflecting down from here and just going up and then going to deflect down again. So if you want to show the values of different actions or different reactions in your structure, you have to just follow this thing. Look, on this question, on this option, show forces, and go to frames and cables. Now here you have three combos set already: my combination, unconfined and unconfined 2. So if I am using my combination, it will use that thing of 1.2 and 1.6. So the thing now, and which thing are you interested to see? Shear along 2-2 plane, shear along 3-3 plane, torsion, moment or moment along. So main axis of moment was 3-3. So I want to see the figure of moment of around 3-3. So this is the, here I am getting the positive moment, a negative moment and a positive moment as well. So if you want to see the values, just go to this and then show values. Yes. So it will show you the different values. So now if you want to see the shear, just go and follow same, use the same combination and shear across the line, because our main shear was along the plane 2-2. That's okay. Look, now it's showing you the shear values. Here this value is minus 24.46, this value is 37.14 and 31.59 and 14.85 are the shear values. So finally we have to design the beam. So for that, go to design, go to concrete frame design and start design and check structures. Look, it has now given us the amount of reinforcement in the terms of feet square. So if you want to see it in inches, just go and change the mode to kph Fahrenheit. So these are the amount of reinforcement, positive and negative reinforcement required over this space to make our beam stable and capable of taking the whole load which was imposed on it. So you can also check whether your design is correct or not. Go to this design tab and then concrete frame design, and now you can check verify analysis versus design section, or you can just check verify all number passed or not. Click on it. So a tab appears and it shows that all concrete frames pass the stress capacity check and are designed. So that means your design is okay. You have designed the beam, press OK, and that's all. You designed the beam. Congratulations. Now you are going to be a master of Sap. But it is only the first step towards your mastery. So I will come back to you soon with some another interesting lecture. So see you then.